Hello students, how are you? Welcome to physics online classes. In the previous video, we discussed about electromotive force and how battery works. In this video, I am going to teach you about very important concept, that is drift speed. It is also called as a drift velocity. Drift speed or drift velocity. As we discussed in the previous classes, when there is a conductor, in the conductor there are two types of the charges: positive charges and as well as negative charges. We are well known that positive charges are fixed in their respective places without having any movement. That's why they are called lattice. What about negative charges or electrons? They move continuously. When they are moving, these positive charges are there, these are the negative charges. Due to the obstruction of these positive charges to the way of the negative charges, they collide with them. When they collide, automatically the speed of discharge becomes halt, even decreases, even sometimes it becomes halt. Again, by getting some energy, this electron starts to travel by increasing speed. This speed is not increasing continuously, the speed is decreasing and increasing, means the speed maintained in a constant way. So this constant speed of the charges that flows through the conductor is called drift speed or drift velocity. From this, we can derive the definition of the drift speed. Charges in the conductor, moves with a constant average speed, a constant average speed. This average speed is called drift speed or drift velocity. Are you clear, children? Look at here. Charges in the conductor. In the conductor, there are number of the negative charges, electrons, moves with a constant speed. They are moving with a constant average speed. This constant average speed of the charges is called drift speed or drift velocity. It is denoted with Vd. So V means velocity, D means drift velocity or drift speed. Now I am going to derive a small formula for drift speed by assuming a situation. Look at here. For example, it is a conductor. Say so. The number of the charges that flows through a conductor. We know what is the formula of current. We know already current means current I equal to number of the charges that flows through a time t is called current. Say sir, no? So for example, number of the charges flow through a current is q, then the time taken to travel is t. From this formula, look at here. This is a conductor. This is the cross section area. What is the cross section area? Cross section area equal to A. Cross section area equal to A, and the distance what I am taking at here is between 2 points VD, between 2 points VD. So distance, I mean width, length, sorry, length. So length is VD. So length is VD. So the cross section area of the conductor is A, and the distance I will consider length VD, length VD. So between this cross section area and VD length, number of the charges flowing. So charges flowing that cross section area and the length of VD is NQ. So NQ means number of the charges. Are you clear? Look at here. I will take a conductor. I will consider the cross section area of the conductor is A. So this is A. And I am imagining a situation, the charges that flows through a conductor is NQ charges. These NQ charges flows through a cross section area A, the distance VD in the time taken, you know, the time is 1 second. What is the time? 1 second. So whatever will happen, total charges that flows through a cross section area. Yes or no? So total charges flows through conductor. How many charges flows through a conductor? NQ charges through the cross section area A with the distance VD. Are you clear? Look at here. So we know already formula of the current. What is the formula of current? I equal to number of the total charges. This is total charges. What are the total charges at here? Total charges how much? NQ AVD by time T. We know already what is the time? 1 second. So I equal to NQ AVD by 1 second. So we can write this as a I equal to NQ into A into VD. If I bring this VD to this side, what will happen? VD equal to I by what is remains? NQA. NQA. So this is the formula of drift speed. So drift speed VD, drift velocity equal to current by number of the charges flows through a cross section area A is called drift speed. So from this, look at here, drift speed VD equal to I by NQA. So do you know about what is density? Charge density. So charge density or electrons density can be written as a I by Q, I by Q. So charge density is denoted with a J. Look at here. Charge density, look at represented with a J. So you can write VD equal to IQ means what? IQ means J, charge density. So J by NA. This is also one kind of drift speed formula. So the main formula is, this is the main formula. So this is the main formula of drift speed. If you know more, by substituting the charge density formula, charge density denoted with a J. So J equal to I by Q. So in the place of I by Q in the formula, you can write J. Then remains NA is there. So this is another formula of drift speed. It is about drift speed or drift velocity. Actually, dear students, look at here. When the conductor is open in circuit, the electrons present in this conductor moves in a random way. On the time, the speed of electrons is equal to speed of electrons. Electrons is 10 to the power of 8 meter per second. It is very important bit. Look at here. They will ask question, what is the speed of the electrons in the conductor when the conductor is open in circuit? The speed of the electrons in the conductor is 10 to the power of 8 meter per second. what is the speed of the electrons when it is connected to the battery? Look at here, the speed, the average speed of the conductor when it is connected to the battery is 0.07 m per second. So when the conductor is connected to the battery, the speed of the electrons, sorry, I written conductor right here, it is not conductor, electrons. The speed of electrons when it is connected to the battery, so then the electron speed is 0.0 millimeter per second. Millimeter per second, it is very less. Look at here, you might have a doubt. Why the speed of the electrons is more when it is open in circuit, but when it is connected to the battery, why the speed of the electrons in the conductor is less? Because, yes or no, it is less value? Because if the conductor is open in a circuit, electrons moves in a random way with speed. That's why the speed 10 to the power of 8 meter per second. If that conductor is connected to the battery, all electrons are arranged in a specific direction, and also that electrons traveling and collide with a positive charges, means lattice charges. When they collide with a positive charges, automatically what will happen? The speed becomes down, it becomes halt. Due to that collision, the speed of the electrons is very less when they are traveling in the uniform direction when it is connected to the battery. That is the reason. So this is today's class. I hope you understand. If you have any doubts, just leave a comment. Thank you everyone. Keep watching.